Good day and welcome. In this lesson, we're looking at general solution given double angles. I'm Mr. Simons, and I hope you help you to understand things better. Alright, so determine general solution given sine 2a plus 4 sine a equals 0. I assume you know 2a means it's a double angle. It's being multiplied by 2. Now, when we double something, we always multiply by 2. So expand using double angle formula. Sine 2a can only become 2 sine a cos a plus 4 sine a equals 0. When I have any amount of terms separated by plus or minus sign, we will always look for a common factor. So there in blue you should see on either side of this plus sign, sine a is common, but I have the value 2 that can divide in itself and 4. So if I take out 2 sine a as a common factor, 2 sine a divided by 2 sine a is 1. 1 times cos simply become cos a. 4 divided by 2 gives me 2, but sine a divided by sine a cancels. So now I can say 2 sine a equals 0 if I apply the 0 factor law, or cos a plus 2 equals 0, and if I take 2 over, cos a equal negative 2. Again, take note, according to this statement, for this ratio cos a, it has a coefficient of 1, meaning this graph can only go till 1 and negative 1 in its range. Therefore, we can't get the value of negative 2, so there is no solution. This side here, shift sign 0 degrees gives me a reference angle of 0 degrees, and sine is negative in quadrant negative. 0, if we treat it as positive, it would be in quadrant 1 and quadrant 2. So in quad 1, 0 plus k360, which just stays k360. Quadrant 2, 180 minus theta plus k360, which simply stays 180 plus k360. Now I must end off and say k element of integers. So hope you follow. Let's look at the next problem. Right, now if you look at problem number 2, they gave me 2 cos a minus cos 2a equal 1. There the angle a is multiplied by 2, so that is a double angle. Right, so I have 2 cos a. Because I have cos a, I must write this in terms of cos. So cos 2a in terms of cos becomes 2 cos squared a minus 1. Take plus 1 and I bring it across the equal sign, it becomes negative 1. So now technically, negative times positive gives me negative 2 cos squared a. Negative times negative would be positive 1, but 1 minus 1 is 0. And there, just write the 2 cos a. So from the 2 there, I should assume you see 2 is a common factor. And on either side of the plus sign, I can still remove cos as a common factor. So negative 2 cos a, cos squared divided by cos a becomes cos a, and 2 cos a divided by negative 2 cos a simply becomes negative 1. So negative 2 cos a equals 0, and 0 divided by negative 2 cos a equals 0. Reference angle shift cos 0 would give me 90 degrees. If I treat 0 as positive, cos is positive, quad 1 and quad 4. So in quad 1, a equal to 90 degrees plus k360. And quad 4, a equal 360 minus the 90 plus k360, which gives me 270 plus k times 360. Cos a there, if I take negative 1 over, become positive 1. Shift cos 1 gives me a reference angle of 0 degrees. Right, so 1 is positive, and cos is positive, quadrant 1 and 4. So for quad 1, 0 plus k360, or I can just say a equal k times 360. Or quadrant 4, 360 minus 0 stays 360 plus k times 360. Right, so that is determining that general solution. Let's look at last problem. Right, and I hope you've subscribed so far, because now I'm doing half angles. Most of your teachers either don't explain it, or it's not in the textbook, or they're not aware of it, or they don't practice past papers. But yeah. Right, sine a cos a equals 0,3. So by now I assume you know sine a cos a, it just shorts a 2 to become a double angle. Alright, so there, if I introduce the value 2 to make it 2 sine a cos a double angle, I have to multiply it by something to ensure that I have that 1 that was given. So we assume you know 2 times half would give me 1, and therefore I've created a double angle. So 2 sine A cos A can now be written as sine 2A. Right, so objective is always to work with general solution, one trig ratio. Right, to get rid of half, I assume you know half times 2 gives me 1. So if I multiply by 2 this side, I have to multiply by 2 that side. So 0,3 times 2, so sine 2A equals 0,6. Reference angle shift sine 0,6 would give me 36,87 degrees. Right, now in which quadrants is sine positive? Quadrant 1 and quadrant 2. So there 2A equal 36,87 for quad 1 plus K360, and for quadrant 2, 2A equal 180 minus my reference angle K360. If I simplify further, always I want A on its own, the angle, so I divide by 2 right through for all of them. 36,87 divided by 2 gives me 18,43, and K360 divided by 2 gives me K times 180. 2A divided by 2 gives me A, 143,13 divided by 2, so 1,57, and there K 180, and K element of integers. If you enjoy and you understand the lesson, please like, share, and subscribe. Only way I can guarantee that you'd stay up to date. There's still many videos that will be uploaded. This is all with the hope that I can help you as far as possible understanding maths better. Right, I would love to do shortcuts for everything, but at the end of the day I believe you first have to learn to do something right before you know how to do shortcuts.